One of the most interesting aspects of Guix is how your entire system configuration is actually a Guile scheme program. Because of this, you can design your configuration in a modular way using the features of the Guile language, including modules. In this video, I'm going to show you the strategy that I use for organizing all the aspects of my system configuration, including multiple machines with shared base configs, modular home configurations, and my own personal package and service definitions. We won't go into a lot of depth on how to write all of these in this video, but I'll show you the tricks for how you can organize your files the way I do so that you've got a good structure in place for your own configuration. We're going to start with an example config that's just a loose collection of files and then migrate it over to my recommended layout. And if you'd like to follow along, you can check out the show notes in the description. There's an appendix section at the very bottom where I have all of the original files, and you can just take those and then start from there and put together your own sort of demonstration .files folder if you want to. All right, first of all, establishing the folder structure. So I'm going to proceed with the assumption that you've already got at least one operating system configuration file, maybe a Guix home configuration, and possibly some custom package or service definitions. It really just depends on how long you've been using Guix and what you've tried to put together in your own config. So the first thing you'll want to do is create a .files folder if you don't have one already. There's another video on this channel about what a .files folder is. I think it's called the basics of .files. It basically is just a folder where you keep all of your standard configuration files that you use across your machines, and generally you check that into source control, like a Git repository that you push to GitHub, Codeberg, GitLab, whatever. There's nothing really special about this folder. It's just a central place to keep all of your personal configuration files. In this example, I'm assuming that you'll create a folder called .files in your home folder. You don't actually have to create a folder called .files in your home folder. You can put it anywhere you like, even with the rest of your code repositories that you clone from GitHub, etc. So whenever you see the ~/.files path in the later examples, just keep in mind that this represents your own .files folder path, whatever it ends up being. So the overall folder structure that I recommend for organizing your Guix configuration is as follows. Under the .files folder, there are two top-level peer directories. One is called config, the other is called files. The config folder, which can have any name you want. It doesn't have to be config. You can pick it. I have mine as David Will, which is my username. It can be anything you want. But usually you will have a folder for the basically the top-level module path for your Guix configuration. We'll talk about what that means in a little bit. But that's sort of the tree under which all of your actual scheme files for your Guix configuration will live. So I'm going to go ahead and just create that here, make dir config. Under that, you're going to have a folder called systems for all your operating system configurations. So basically for each machine that you configure Guix for, you would have an individual scheme file for each of those machines. I prefer to name them all using the host name of the machine, and you'll see why in a little bit whenever I start talking about aliases for common commands. So I'm going to create a config/systems folder here. Also a services folder for any custom system level services that you might create. We won't be talking about any of those in this video, but there may be cases where you want to have a system level shepherd service or just general Guix service configuration. So the services folder would be a place to put that. Also, there would be a packages folder for your own custom package definitions. This ends up being a pretty useful thing about Guix, being able to create your own custom packages that you just use in your own configuration without having to pull them from some other channel or from the Guix repository. So let's create a packages folder for that. Then there is the home folder for your Guix home configuration, if you have one of those. So any of your home environment configs would go here. We'll take a look at an example of that in this video. And there's also a subfolder of that called services for any custom home services you create. So home services are kind of a parallel to system services. They just have their own sort of subfolder path. This is the way that it's organized in the main Guix code repository, and that's the reason why I'm following this pattern here, just so that there's some consistency between how we set up our own folder and how the actual Guix code base is organized. So make dir config home, and then make dir config /home/services. And the last one is the files folder, which is at the top level under .files. This actually is not going to have scheme files in it. This is actually meant for miscellaneous files that are needed for your home configuration. Could also be for your system configuration as well. But when we get into the next video, or one of the next videos about how to set up your .files with Guix Home, this folder will actually play a role, because maybe you have a lot of static configuration files, like maybe a Sway configuration or some other programs that you've configured that you don't want to configure with Guix Home, but you want Guix Home to symlink those files into your home folder. So this would be the place where you would store those kinds of files. We won't be talking about that more in this video, but we'll definitely talk about it later. So this is your folder. You can put whatever files or folders you want in the structure as necessary, but this is just the bare minimum needed for the strategy that we're going to look at today. I will say that maybe don't put too many things in this top level folder path, because this will be treated as a Guile module path, which we'll talk about in a minute. That could cause some trouble, but I think you'll be okay no matter what. I have a bunch of folders in my dotfiles directory, so it hasn't really caused much of a problem for me. Just something to be aware of. Okay, so now that we've got our folder structure settled, the next step is to migrate our existing configuration files into the appropriate folders. Let me just pull up that folder in DRED first, so that you see what we have here. We have the config path, home packages, systems, etc. So we're going to move things into this folder. So we're going to start with 4 files, 2 system configuration files which share a base configuration file, and a home configuration file that has a custom home service and a simple package definition file as well. We're going to move all of those from being single configuration files into this folder structure. So if I go into my original files folder here, we have the full 4 files here. So I'm going to go ahead and start moving in the system configuration files. And let me move some things around the screen here so we can see this as I'm doing it. All right, so here we go. So we're going to start with the system configurations. We're going to start with the Gemini config. So what I'm going to do is copy this into the dotfiles folder under config/systems. So now that will be there. If I go look at the dotfiles folder, I really need to split this window. How about this? Okay, got a little popper action going on here, so it's not letting me. Let's split this window, and then I'm going to split this in half. Cool. So I'll open up DRED to go to the dotfiles path, and then in the other window here, I will go to the original files path. If I can get over to it. All right, so we're going to copy Gemini over to the let's see, systems path. So I'll go ahead and do that. I think I did that already. Now I'm going to open up this Gemini.scm file. So we've already got a base configuration here. This is normal Guix configuration that you could actually load in using Guix system. What we're going to do to start off with is to turn this file into a module, because what we're trying to do is modularize or turn our existing configuration files into Guile modules so they can be treated as actual Guile code. I mean, it's already Guile code, but now we're going to treat it more like a code project in a sense. So I'm going to change this use modules expression into a define module, because what we're doing is creating a new module here. And I'm going to turn this into config systems Gemini, because it's the Gemini module. Now, once we've done that, we actually have to do some extra stuff to turn these module imports, because that use modules expression you saw before is importing modules. It's importing the GNU module and the Guix module, both of which are coming from Guix itself. So to do that, we have to use the syntax for use module. And we're going to have to do that on each of these lines, which is a little bit unfortunate because the original use modules syntax was a lot cleaner than this. But this is just the way that Guile modules are defined, and their dependencies are specified inside of your module files. So we have a define module expression. It says what the module sort of name is, config systems Gemini, and then the 2 use module expressions that we have at the top of the file here. So you should pay attention to the fact that this name, config systems Gemini, mirrors the path that the file is under your load path. So we're going to treat our .files folder as a load path for Guix or for Guile itself, which means that anything under that path now becomes part of Guile modules. So here, the folder path is config/systems/gemini.scm. That has to be consistent with the name in this module file, or you might run into issues. You'll either see errors or things won't load correctly, etc. So make sure that whenever you create a file under this folder structure, that the name of the module that you put in here is the same as the folder path where the module file lives. Okay. So let's see. Now what we need to do is move the base system configuration over, because currently we're including the base system configuration file, which is a cheap way to do this if you don't want to have to turn everything into modules. But we're going to take this the full way and turn our base system configuration over into a set of modules as well. So let me see if I can pull that up here. I'll jump back to this folder. I'm going to copy base system over. All right, so now I'm going to go into the base system file. We're going to do the same thing here. We're going to turn this into a define module. So define module, we're going to do the same kind of use module syntax here. I'll copy that over and then I'll drop that in. Okay, so that's pretty good so far. There are these use package modules and use service module expressions here. Those are kind of a special convenience that Guix provides to make writing imports for packages and services easier. We're going to talk about that in a later video, but you can just leave these how they are. You don't have to convert these into use module expressions because sometimes you'll end up with like 15 or 20 imports. And you don't really want to have that many use modules inside of your module definition. It gets a little bit annoying. I'll put config systems base system here. And then we still have our base system being defined. But to make sure that anyone who imports or any module that imports this base system module can actually get access to this base system that we're sharing, we have to export this symbol called base system. So there's a special syntax inside a define module called export. And I can say export base system, and that's going to allow me to export that symbol so that whenever Gemini imports this module, it will have access to that base system symbol. So if we go back over to the Gemini.scm file, just the right folder path. Yes. So we can get rid of this include because we're going to import that module instead. So I'm going to go in here and say use module config. Good typos today. Config systems base system. All right, so now that will allow us to get this base system symbol from the config systems base system module, and then have that shared configuration. Let me see what else I'm missing here. Yep, so we got the use modules lines. Also, I should say, I'm kind of riffing on the stuff that's already being written in the show notes here. So if you want a more organized presentation of the information I'm giving you, you should definitely check out the show notes and take a look at all that. Okay, so we've converted the base system into a module. All right, and we got the use module in for base system. We remove the include line. So yeah, now we're gonna do the same thing to the Taurus configuration. So I'm gonna go over to the Taurus file here in the other folder. And I'm gonna copy that across. Now I'm gonna go back into Taurus. And then the same thing here, define module. We're going to give it the module name, config systems, Taurus. And then we're going to use module on that and drop that in. We're going to fix these lines up. Okay. We're also going to need to import that configuration, the base system configuration, but I'm going to wait on that for a minute because I want to show you a trick in a little bit. So we got that configuration moved over as well. So that's all three of our system configuration files moved over to be modules under the config systems modules path. We're going to experiment with these in a minute, but first I want to go through splitting up the home configuration into various module files first so you can see what that process looks like. So let's get back over to our notes here. So now that we've got our system configurations converted to modules, we're going to convert our home environment configuration the same way. Currently, that's all in one file here. I'm not going to put it in the same folder. I'm going to go back to the home folder path to set this up. So let me go back over to this dired. I'm going to copy over home config to the home path. And let's take a look at that file as well. All right, so we've got a lot of imports here because we're doing quite a few things. We've got a package definition here for Emacs Super Save. This is my own package definition. This is actually now merged into Guix itself, but we're just using it as an example. We also have a home service definition for an Emacs config service type, which is a basic example. And then the home environment configuration that just pulls in the Git package and applies this home Emacs config service type. So what we want to do is turn this file into a module, but we also want to move the package definition and that service definition out into their own module files. So let's go ahead and start that work by moving the Emacs Super Save package over to its own file. I'm going to delete that out of here. And then I'm going to go over to the packages folder and create a file called emacs.scm. I'll paste this in. Now I'm going to create a module, define module, config packages Emacs. And then I'm going to have to do some imports here. So I need to grab the relevant imports from this use modules expression. I think these are the things that we need here. So I'll go back and drop those in. I'm going to do the same thing here that I did before with use module. and then just go grab this and paste. There's probably a more efficient way to do that, but you know, this is how it goes in Emacs sometimes. All right, so here we go. So we got those things pulled in, config packages Emacs. All right, so now we've got this package definition here, but we also need to remember that we need to export the Emacs super save symbol for this package. So we've used define public here. In fact, define public is another way that you can export symbols without having to do an export. It's a special syntax inside of Guile. It's not a thing that's in Scheme by default, but you can use define public for this, or you can use the export syntax. Sometimes it's better to use export instead, just so that you can glance at the top of the module file and see which symbols are being exported. But I will say it is a lot more convenient to just use define public in a lot of cases, so you might want to just do that instead. Okay, so we got this package definition moved out. I'm going to go move the service configuration as well. So let's do that. I'll grab these files, and I'm going to go drop those into home/services/emacs-config.sem. Paste those files in, or sort of the service definitions in. I'm going to grab these lines and put them into a define module config. Let's see, home services. Is that right? Yeah, home/services/emacs config. And we're also going to have to do some imports here. So use module. And I think that's all I need for these. So we got the GNU Home Services, and then I will grab this line and paste it a couple times. And this is going to import all the things we need for defining our service. So we got our home Emacs config profile service procedure and our home Emacs config service type. The only thing we really need to export from this module is the home Emacs config service type. So I'm going to add that to the exports list up here. So export home Emacs config service type. And that will do the job there. So now that we've got the home service and the package definition put into modules, there's one last thing we need to do here, which is to say use module config packages Emacs, because we are actually using our Emacs super save package that I defined right here. So let's make sure we do that. We're also pulling in GNU packages Emacs to get the Emacs package here. So that should be enough for getting that all set up. So now back in this file, we've already got our home, our home environment configuration set up. We can get rid of a few of these things here. I think we can just leave GNU Home. There's one thing I'm missing here, which is GNU packages version control. We can also add our config home services Emacs config for our Emacs config service type, which we're using here. I think that should be enough. So that's our home configuration moved in. Last thing is to change this into a defined module for config home config. Home config is kind of a lame name for this, but this is what I'm using. In some cases, you'll have different types of home configurations for different types of systems. It really just depends on how you organize your own configuration, but we're just calling this one home config for now. So I'll pull that in, and the last one is here. Let's just get all these straightened up. All right, so we've got all of our files turned into modules now. We split apart the code that was in our home environment configuration into multiple files into their own modules. We've also got our modularized system configuration set up the right way. So the next thing to do is to test what we've done to make sure that everything we did is correct. And let me just move on down through all this. Make sure I didn't miss anything. I'm pretty sure we got all this stuff. All right, so actually the first thing we'll talk about is how to actually use these dot files with Guix. So the trick to this strategy is to add your dot files folder to the Guix load path so that your configuration modules can be found. So because Guix is really just a way to configure a system using Guile's scheme, Guix itself is leveraging Guile to enable you to write your configurations kind of like a configuration file, but it's really just Guile scheme code. Because of that, you can add additional folders to the load path of the Guix process so that you can add additional modules of code to Guix so that you can load it however you like. And that's basically what we're going to do with our dot files folder. We're going to add that to the load path so that our modules will now be visible mainly to each other inside of Guix. So the standard way to do this is to use the -L or the -- load path parameter to the standard Guix commands. Many of the commands do accept these. The ones that you would most commonly use are Guix shell, Guix system, Guix home, Guix build, and Guix REPL, because those are kind of the things you would use with configuration files that you might have written as modules. So for example, if you want to apply an update to your system configuration or apply an update to your system from your system configuration, you would invoke Guix system reconfigure with the -L. As you can see right here, we have Guix system -L dotfiles reconfigure, and then whatever the path is to the configuration file you want to use. That will make sure that when you load up your Gemini.scm configuration file, if it tries to import modules from your configuration, it will find them because you've added that your dotfiles folder as a load path to Guix. But obviously, this is a lot more typing. If you're going to have to type in this -L dotfiles every time you want to run a command, it's going to get a little bit annoying. There isn't really an ideal solution for adding your dotfiles path to Guix commands by default. There are some, but they're a little bit hacky, so I don't really want to discuss them. But what you can do is create aliases for your most frequently used commands and add them to your shell configuration. So I typically add shortcuts for applying my Guix system and Guix home configuration so that I can just type a short command instead of having to go write the whole thing out. So for instance, here are two aliases that you can set up in Bash or Z shell. One is called update-system, which just runs sudo Guix system -L dotfiles and then reconfigure. One of the things that it does here actually is that it uses the hostname command. If we go into eat, if I type in hostname, it will tell me that this machine is called Phantom. So you're basically just inserting the hostname into this file path. And if you use the strategy that I said before about having your configuration files, your system configuration files being named with the hostname, then this will cause that to be updated. This will cause the configuration file for this machine to be applied by just using this update-system alias. Similarly, we would add an update home alias that runs Guix home and then reconfigures that system, adding the dotfiles path to your load path, and then just pulling in whatever configuration file you use typically for your Guix home config. You would have to obviously change that for however you set up your home configuration. All right, so now that we know how we can actually use them, let's actually talk about how to test our changes to make sure that what we did is going to work. So the first thing I'd recommend before actually trying to use your configuration files is to try loading them using the Guix REPL. What this will do is to help you detect errors in your configuration files, like syntax errors or maybe missing module imports, because in some cases, when you try to run Guix system or Guix home to apply a configuration, if your configuration is loading code from another module and there's a syntax error or some other kind of error in a module, Guix will give you a vague error sometimes, and it won't be clear why it can't actually load your configuration. So the trick to use to check this out is to go use Guix REPL to try to load individual modules of your configuration and see which one of those actually gives you an error. But I want to show you this strategy first so that you can use it as part of your workflow for introducing new configuration files or changes into your your module configurations. Okay. So what you need to do here is in a terminal, run Guix REPL -L and then give it the path, your configuration files, your .files path basically. And then inside of that, you will be able to, let's see, Guix REPL -L. I'm already in .files. I think I can just do dot here. So we can do something like use config home config to pull in the home configuration file. So we got a problem here in the home config file, it seems. I must have made a mistake there. So let me go into my home config file. It appears that for each of these lines, I'm calling them use modules instead of use modules. So that was actually not intended in this demonstration, but it does show you that sometimes it's very easy to get this wrong. So I made the changes to fix those use module lines. So the thing you need to do is to exit the REPL before you try to load the module again, because sometimes it will cache the state of the module and it won't give you the errors again, or it won't give you accurate information about whether you fixed the issue or not. So if I were to use the up arrow to run this use command again, I think it doesn't tell me anything. Okay, service type invalid specifier in subform. Yes, that's a different problem entirely. Okay, so we'll move on to that in a second. Anyway, point being is sometimes it's good to restart the REPL before you try to load the module again, because sometimes it will trick you into thinking you fixed a problem and you didn't actually fix it yet. So to exit the REPL, you use -Q. It takes you back to the terminal. Then you can run the Guix REPL L again to refresh the REPL, and then you can try to do the use config home config, or whichever module you're trying to load. And this is a special command inside the REPL. It's basically just calling use modules effectively, and whatever module path you give it. So it's just a quick way to import a module into the REPL. So we're getting another error here about the Emacs config service file. Apparently I did something wrong there. So let me go there into the Emacs config.scm file. It says invalid field specifier in subform. What did I do wrong here? Maybe I missed an import. Invalid field specifier of service type. I think what I did is I did not do a parenthesis balancing correctly in this, and I got something wrong here. So I think I forgot an in paren on this extensions line, and I messed that up. So it just goes to show you that you can make mistakes really easily, and it's good to use REPL to just double check that. So now it tells me that everything's okay, but I don't really trust it. So let me exit out of the REPL using -Q, and then go back into the REPL and then run it again. And this time we don't get any errors. Just to double check, I'm gonna go and say use config home services Emacs config. And that seems clean too. So now I know that at least there's no syntax errors and there's no obvious other issues in the configuration file that will prevent this from working correctly. So definitely a good strategy to use, both to verify whether the new things you're adding are correct, or if you get weird errors whenever you're trying to run Guix Home or Guix System to apply a configuration. Definitely use a REPL to check this out. It's a little unfortunate that Guile doesn't do a better job of surfacing these things, but that's just the way it is sometimes whenever you're using more, what do you call it? Complex artisan software. I don't know, I just made that up. Okay, I think that's everything I wanted to say about this particular topic. All right, so basically, oh yeah, so one thing to point out is that this approach will not find all possible problems with your configuration files, really only those that would affect the loading and compilation of the configuration code. Anything that would be executed at runtime in your code may not be discovered until you actually try to run the code, but it's okay because usually you'll get a pretty good runtime error at that point to tell you that maybe you're trying to use a symbol that is not imported. It will give you sort of more information about where it's happening in the code, so you won't have as many cryptic errors whenever things are being executed. So just keep that in mind. Even though the code loads correctly in the REPL, it may still not execute correctly. So the next step would be to go and try to apply the configurations to your system, which is kind of out of scope for this video. We'll talk about stuff like that in another video, but I just wanted to show you those strategies and make you aware of that. All right, so I hope this video gave you some ideas on how you can structure your own Guix configuration. Please feel free to leave any questions in the comments or head over to the System Crafters forum to discuss your thoughts with the community. In future videos, we're going to discuss how to write all of the various parts of your Guix configuration, like all the things you saw today, and then put them together using this specific folder strategy. So make sure to subscribe to the channel and click the bell to be notified when those are released. Also click like if you like this video, because it kind of helps sometimes. So anyway, thank you so much for watching today. I hope you are doing well. I hope you enjoyed the video. Until next time, happy hacking. We'll see you.